Okay, we're going to talk about radicals in this geometry lesson 19. And so a radical is just a root. We normally see them as square roots, and a radical cannot be in the denominator. So we can't ever leave those radicals in a radical place, such as the bottom of the fraction. We have to fix it by finding an equivalent fraction that no longer has a radical in the denominator. We call it rationalizing the denominator, because what we're doing is making that denominator a rational number. Just like if we want to add 1/2 and 1/4, we can change this 1/2 into an equivalent fraction. Hopefully off the top of your head, you know that it's 2/4, but how do we get this to be 2/4? Well, we multiply it by something that's just 1, and what we multiply by is 2/2. Because 2/2 is 1, and 1 times 1/2 is still 1/2, but we're going to make it look different. When we multiply this 2 on both the top and the bottom, or the numerator and denominator, we get 2 times 1, which is 2, and 2 times 2, which is 4. And that's this fraction, and now we add the 1/4 to it. And now we can add these fractions because the denominators are the same, and we change this denominator by multiplying by 1. Over here. It's just that we made the 1 2/2 so that it would be something that would make that bottom a 4 as well. So that's what we're going to do. This is an irrational number. There's this radical in the denominator, and we can't leave it that way. So remember, we make equivalent fractions by multiplying the numerator and denominator by the same number, because we're just multiplying by 1. Because this is a square root of 3 and the denominator, we just want to multiply by the square root of 3 on both the top and the bottom, because that makes this just 1. When we do that, on the top, we multiply things outside the square root and inside the square root, but we can't multiply them together. So we just leave them separate. 5 times the square root of 3. In the bottom, we can multiply both these 3's because they're both inside the square root. So the square root of 3 times 3, which is the square root of 9. Notice the top is staying the same because we can't do anything more to it. 5 square roots of 3 over the square root of 9. And the square root of 9, hopefully you know, is just 3. So because we had 2 3's in here, we brought them outside the square root because there were 2 of them inside the square root, so 1 comes outside. Or you can multiply the numbers and know that it's 9, and the square root of 9 is 3. Now there's no more radical in the denominator. And we're finished. This is as simple as this one can get. So there are many ways to do some of these problems when they're a little bit bigger numbers. I'm going to show you 3 different methods here. But in the end, you can do it however makes sense to you. It doesn't matter if you reduce the fraction first or if you rationalize the denominator. However gets you to the right answer at the end is a fine way to do it. So we're starting with 4 over the square root of 8. So if I take the same approach as this one up here, I'm just going to take what is in the denominator and I'm going to multiply it on the top and the bottom. So in this case, I use the square root of 8 and I multiply it in both the numerator and denominator because this is just multiplying it by 1. And I can do that as many times as I want and it's still the same fraction. In the top, we get 4 square roots of 8. And in the bottom, the square root of 8 times the square root of 8 is just 8. Because really, we're going to end up having the square root of 8 times 8. And when there's 2 8's in there, we can pull one of them out, or we can pull them out as 1 8 right here. Okay, now I look and I see this is rationalized, but it's not reduced. I can take a factor of 4 out of the top and the bottom. When I take a factor of 4 out of the top, I get 1. When I take a factor of 4 out of the bottom, I get 2. So now I have the square root of 8 over 2. And this looks like it might be finished, except if we've worked with square roots for a while, you might think that you can factor this and reduce this square root just a little bit more. So 8 is really 4 times 2, and 4 is a perfect square. So I can bring that outside of the square root as a 2. So 8 is the square root of 8 is really 2 times the square root of 2. And then this 2 stays in the bottom. Now, when we get to this point, we see that we can reduce the fraction again by a factor of 2. and we get just the square root of 2. Let's see this a different way. If I want, I could reduce this fraction first. When I have 4 over the square root of 8, I can say, I know that the square root of 8 is not as reduced as possible. So it's really 4 times 2, and that 4 is a perfect square, so I can take the square root of 4 and make that a 2 on the outside and a square root of 2 on the inside. Now I can reduce this fraction just a little bit by dividing both the top and the bottom by 2, 2 on the top and 1 on the bottom. So now I have 2 over the square root of 2. Now I'm going to rationalize the denominator by multiplying by the square root of 2 on both the top and the bottom. Remember, all we're doing is multiplying by 1. Anything over itself in the fraction is just 1. So multiplying across the top, we have 2 square roots of 2, and across the bottom, the square root of 2 times the square root of 2, which is the square root of 4. The square root of 4 is just 2. Now we have 2 square roots of 2 over 2. We can reduce by a factor of 2, and we're left with just the square root of 2. Some people might look at this and say, okay, the square root of 8. What could I multiply 8 by to get a perfect square inside the square root so that I can take it out of the square root and no longer have that radical in the denominator? So you might say 8 is kind of close to 16. 16 is a perfect square. So I'll multiply both the top and the bottom by the square root of 2. When I do that, across the top, I get 4 square roots of 2, and in the bottom, I get the square root of 16. And the square root of 16 is 4. Now I have 4 square roots of 2 over 4. I can reduce right here, and I'm just left with the square root of 2. Now, this might be the fastest method, and you might try this, but honestly, I don't see this all the time. In fact, I rarely do. I usually start with kind of method 1. Maybe I do method 2 if I see some things that can be reduced. So method 3 is really cool, and maybe you're going to look for it. Maybe you don't want to be bothered and you just want to multiply what's in the denominator to get rid of it and then start some reduction. So any of these methods are fine, however you would like to think about it. So we can reduce radicals before or after we rationalize the denominator. And you can even get crafty and think of an exact radical or an exact square in the bottom and multiply by that radical. If we do an addition problem with radicals in the denominator, we first want to rationalize the denominators and then find common denominators and add the fractions together. You actually can, yes. So with radicals in the denominator, we want to rationalize first and then get common denominators to add them together. You can do it the other way, but sometimes it makes it a little bit more complicated. So if this is our first problem, we have 3 over the square root of 5 plus 7 over the square root of 2. So I'm going to rationalize this one by multiplying both the top and the bottom by the square root of 5. So I just took what was in the denominator. I'm going to multiply it on the top and the bottom. And then I'm going to work kind of simultaneously. So that's that first fraction. And then the second one has the square root of 2 on the bottom. So I'm going to multiply by the square root of 2 on both the top and the bottom right here. So I'm working 2 problems together. Over here, I have 3 square roots of 5 over the square root of 5 times the square root of 5, which comes out as just a 5. So I have 3 square roots of 5 over 5. And on this one, I have 7 times the square root of 2, and then square root of 2 times the square root of 2, which is 2. So now these are my 2 fractions that I need to add together. Now I have a 5 for one denominator and a 2 for the other denominator. I need them to be the same denominator so that I can add them together. So what I'm going to do is make 10 my common denominator. And to make this a denominator of 10, I'm going to multiply the top and the bottom by 2. So then I'll have 3 times 2. They're both on the outside of the square root. And so that's going to give me this 6. And then the square root of 5 is right here. And then down at the bottom, I have 2 times 5, which is 10. This second fraction, if I want 10 on the bottom, then I'm going to multiply by 5 over 5. So right here, 7 times 5 is that 35. And then I have the square root of 2. And then 2 times 5 is 10. So now I have the same denominator, and I can put them all together as one fraction because the denominator is the same. Now up at the top, I really can't add anything together because this has the square root of 5 in it, and this has the square root of 2. We can multiply what's under the square roots together, but we cannot add the square roots unless they're the same. So in this case, it's like we have an X variable and a Y variable here. I can't add 6X to 35Y because they're different variables. So these are different amounts and I can't add them together. All right, so a couple of practice ones. If we want to rationalize this, remember that that means I want this to be a rational number in the bottom. And the easiest, simplest way to do that is just to multiply by what it already is on both the top and the bottom, because I'm really just multiplying by 1. So the square root of 6 over the square root of 6. On the top, I get 5 square roots of 6. On the bottom, I get the square root of 6 times 6, which is 36, and the square root of 36 is 6. So I have 5 square roots of 6 over 6. And that's as simple as I can get because there's nothing to reduce in this fraction. Number 2, 9 square root of 2 over the square root of 3. Best way to do this is just to multiply by the square root of 3 on the top and the bottom. So you should be seeing this pattern. When I multiply by the same square root that's on the bottom, I'm going to get it to come out of the square root as a rational number. It's 3. So the square root of 3 times the square root of 3 is just 3. In the top, I'm going to multiply, well, the 9 doesn't do anything because there's nothing else to multiply it with. And then the 2 is under a square root and a 3 is under the square root. So 2 times 3 is 6. So it's the square root of 6. Now, 6 cannot come out of the square root at all, but I do see that I can reduce 9 over 3. So 9 over 3 is really just 3. If I divide this by 3 and this one by 3, so I have 3 square roots of 6, and I'm done. This one says subtract and reduce to simplest form. So I could reduce right here, or I can find a common denominator and subtract them and then try to reduce. I'm going to go ahead and say that I see some things in here that I can reduce by, so I'm going to do that first. So the square root of 12 is also equal to the square root of 4 times 3. And 4 is a perfect square, so it can come outside and be 2 square roots of 3. So 2 square roots of 3 over 9 minus the square root of 18. Well, the square root of 18 is 9 times 2. 9 is a perfect square and can come outside as 3, so I have 3 square roots of 2 over 4. And so I can't reduce anything here, but I did make the square roots look a little bit better. It might help me in the end. So now I need to get a common denominator. With 9 and 4, I'm just going to make it 36. So to get 36 as my denominator, what am I going to have to multiply by? On this one, it'll be 4 over 4. And then we'll do that one in a second. So 4 times 2 is 8 square roots of 3, and 4 times 9 is 36. On this one, we'll multiply by 9 on the top and the bottom. So 3 times 9 is 27 square root of 2 over 36. Remember, I want to combine these together. So 8 square root of 3 minus 27 square roots of 2 over 36. And unless 8, 27, and 36 have a common factor, I can't reduce. I also cannot actually put these together because this is the square root of 2 and this is the square root of 3. And so I can't combine these. So actually, in the end, this is our simplest form. There's another practice one. This one has the square root of 3 and the square root of 5. Remember at the top of our notes, it said actually it is better to rationalize the denominator first and then find the common denominator. So to rationalize this denominator, it's just the square root of 3. So I'm going to multiply the top and the bottom by the square root of 3. So we'll have 24 times 13 times 3. That would be the square root of 39. And then on the bottom, the square root of 3 times the square root of 3 is just a positive 3. Now the second fraction is over the square root of 5. So I'll multiply by the square root of 5 in the top and the bottom. Across the top, I'll have 3 square root of 10, and the bottom will be 5. Now I want to find a common denominator, and that's going to be 15. So to get this one to be 15 in the denominator, I'm going to multiply by 5 in both the top and the bottom. 5 times 24 is 120 times the square root of 39. And then over here, I'll be multiplying by 3. So 3 times 3 is 9 square roots of 10. And then 5 times 3 is 15. So I'm going to rewrite it over here, all over the same denominator. Now I'm going to look, does 120, 9, and 15 have a common factor? It does. They all can be divided by 3. So when I divide this one by 3, I'll get 40. This by 3 will be 3, and this one divided by 3 will be 5. So now I have 40 square roots of 39 plus 3 square roots of 10 all over 5. And now there's nothing else that all 3 of these can be reduced by. So this is my simplest reduced form. Last one down here, I have 10 square roots of 10 over the square root of 7 minus 2 square roots of 6 over the square root of 11. So I'm going to multiply this one by the square root of 7 on both the top and the bottom, and this one I'll multiply by the square root of 11 on both the top and the bottom. Now I'm going to do a trick here that I will show you. These start to get some big numbers inside the square root, so I'm going to actually leave them factored. So on this one over here, I have 10 on the outside, and then inside the square root, I'll have 10 times 7. And I'm going to leave it factored, and that's going to be all over 7. Over here, I have 2 times the square root of 6 and 11, so I'm going to leave those factored, and that is all over 11. Now I need to get a common denominator. So I think it's just going to be 77. I'm going to just set up my fractions here. So to get this to be 77, I'm going to multiply by 11 on the top and the bottom. 10 times 11 is 110. The square root of, we can leave it this way for a little bit. I thought we might be reducing something in here. And then this one, we're going to multiply by 7 on the top and the bottom, and not the square root of 7 anymore. So this 7 is on the outside. 2 times 7 is 14. Inside will be 6 times 11, and then 7 times 11 is 77. So I don't see anything that can come out at this point, so I'm going to go ahead and multiply what was inside my square root. And I'm combining them. So 110 square root of 70 minus 14 square root of 66 all over 77. Now the only factors of 77 I can think of are 7 and 11. This can be a factor of 11, but this one is not. So there's no common factor between all 3 of these. So this is our final answer.